I'm Megan McDermott with High Performance Building Solutions. I'm the architectural engineer of the company, and I work out of Charlotte, North Carolina.
And I'm Francis Conlin. I'm the engineer in the company. And what do we do? That's always been a challenge for us to explain exactly what we do with buildings, because we work with so many different types of buildings. And we finally came to the words that we just make buildings behave, which kind of is an all-encompassing description of what we do.
So Francis, how's business?
Business is pretty good. We stay busy. One of the things that I like about what we do is, we work on a lot of different kinds of buildings. So I could be working on a 500,000 square foot building one week, and then next week be working in a mobile home in East North Carolina. So I like that. I like the variety, and we seem to have enough of it. What do you think?
We stay very busy going all over the country. Next week we get to go to Maryland.
Yeah.
And so we went to Fort Bragg today, and we get to go to Blues Creek tomorrow. What types of buildings do you work in?
Well, I think we talked about that. So Blues Creek is a power plant, and we're working in some of their buildings there. Houses, I don't work in a lot of houses right now because we're more focused on commercial, but still I have contracts with national housing builders, and they fly me all over the country to look at some problem buildings they have. What kind of buildings do we not work in? We've done schools, we've done hospitals, we've done assisted living facilities. Haven't done a grocery store in a long time, but we did some early work in those also.
Mm-hmm. We've done a lot of industrial facilities the last year.
There are a lot of problem buildings out there. So, if you look at buildings, there's opportunities. We see opportunities in all the buildings, so it doesn't matter. I actually had some work a couple of years ago. We did 2 or 3 industrial refrigerators. One of them was a 500,000 cubic feet refrigerator for a company I can't say on video.
Describe your typical workday. Phone starts ringing at 7 a.m. and we're usually on the road before then, on the way to whatever job and whatever state we're heading to. And then usually the afternoon and the evenings are spent writing reports on whatever problem building we looked at for the day.
Yeah, I have 2 kinds of work. One is field work, like you're describing, and the other is sometimes I get into forensic work or research work where I spend hours and hours, reading text, reading reports, trying to decipher what was going on to, figure out, the best solution or what the problem really is. So there's a lot of report writing, a lot of reading. I spend a whole lot of time looking at magazines and books. I buy books all the time, and spend a lot of time doing that. Probably 50-50, which I really like, because I can veg out here for 3 days reading or writing, and then by the time I need to get out and walk around, there'll be a field job I have to do and get up. This weekend, I'm leaving here Sunday to fly to, where am I going to? Ohio. Spend the day there and fly back on Tuesday morning. And then I have to write that report. And then next week, we're doing a really interesting test on Friday in Charlotte.
Mm-hmm. Describe your typical client. Anybody with a problem, whether it's high utility bills, moisture, they're building a new building and they want to make sure they get it right. Basically, anyone dealing with buildings.
Yeah, I think that's right. I think it's people who care. I mean, not everybody in the building industry cares, and that's what we run into. There'll be an owner who cares. There'll be a architect that cares, or even a builder, construction guy that really cares and wants to get it right. Mm-hmm. And if it's a new building, they'll on an ideal client will call us in early, have us look at plans, and have us help figure out the best way to get something done. And on existing buildings, it's a lot of it is like, what went wrong here? Why is this problem occurring? What's happening? What's the best way to fix it? Yeah. And so I think of their people that care about their buildings.
Mm-hmm. Today I got a call from a private school, their buildings and planning board, wanting to make sure they get their new construction project right the first time. So.
And you said they were doing value engineering right now, and we're afraid of that because we've seen some of those people do that before. Some of those same people.
They value engineer insulation out, or insulation levels, or air sealing, or specific air barrier material because they say it's too expensive and end up with something cheaper and not as effective in the long run.
So you do a lot of plan reviews. Tell me what you do when you do a plan review, because fortunately I don't have to do those.
So when I do design reviews, we end up going through the plans, whether it's design documents or construction documents, and we review them for mainly building envelope issues. So we look at the continuous air barrier, thermal barrier, and moisture barrier to ensure they're continuous, all the continuity is there, details are there for the contractor to build it right, and then we'll go through the specifications and make sure the materials are specified, any quality control issues are specified. What else did they do? A lot of times it's just catching things before the contractor starts to build them.
And I do a little bit larger share of moisture problems in buildings, so that's probably 60% of my time is spent looking at moisture issues. So in the design review, I'm always happy to see that we're able to correct moisture problems before they happen, and that's always been a big issue.
How and why do clients normally contact you?
I don't know how contractors find us all the time. I know what I do and what you do are.
So what do you do when you get a call, when someone calls your cell phone? How they get your number?
I don't know how they get it. I don't think I asked that question.
I always ask that question.
Well, you're
Not
good. So
from
you
our
answer.
website.
Not from our website. No, that's been a sad story from the beginning. But I won't say that. We just really haven't had to rely on the web page for any work. Pretty much it's been word of mouth so far, and I spend a lot of time talking to people about what we do, and pass out a whole lot of cards, and I talk to people on the phone all the time about their problems, and phone time is free, although I don't really want to get 8 hours of phone calls a day. Don't use that. Well, no, I talk on the phone to people all the time. I'll have people that will call me while I'm driving, and I'll pull over and just send me some pictures, and I'll pull over and look at them and tell them what I think, and tell them if I can help them or not. But I've been doing this for a long time. I mean, I'm 35 years, 40 years of building science work, back when blower doors were brand new, and I have a deep bench of contacts that will call me on stuff, which is very nice.
So normally people find us because they were referred to us by someone else, either someone we've helped before or someone who said, I saw Meghan and Francis teaching this class, or call Meghan, she knows how to do a big blower door test. That's usually what it is that they've heard of us from someone else, or they've been to a class we were teaching and just call and tell us what their problem is. Normally it's someone calling because they have a problem, and so they'll call and they'll kind of describe their problem and work through it with them, or figure out if there's an inspection or a test we can do to verify or document what's going on. Describe one of your favorite projects.
There are so many. Probably the one that I've had the most fun with was a really interesting project, and it was a large refrigerator that I mentioned earlier that was a 500,000 cubic feet. To give it better perspective, it's 120 feet by 60 foot footprint and 75 feet high. So it was an industrial type refrigerator, and they were sucking in humid air and getting moisture all over, or condensation in the refrigerator and dripping on all their boxes, which had pharmaceuticals in them, and making little mold spots, and it was a bad deal. And so I was there to basically find where the holes are. It's a huge building. And I got the blower door, and my plan was to pressurize it and my big smoker and fill the whole room with smoke and watch where the smoke came out, and that didn't work at all. But fortunately, I had a backup plan that I learned working on RVs, because RVs, when RV has a hole in it, what they do is they spray it with bubble soap and pressurize it with the fan, just like you do a tire. So we did that with this huge refrigerator. We pressurized it and got bubble soap. We got all the bubble soap at Walmart and sprayed the walls with it until we found out where all the leaks were. And of course, they just bubbled out. It was great. It was a great visual for building science, and probably something that's not been done very often.
And why did they have this problem?
Well, they had the problem because of construction issues. This was obviously an on-site construction when you have a refrigerator that large. A lot of the refrigerators go together with tongue and groove sandwich panels, which have butyl, never cure butyl, so you squish them together and the seal should be there forever. But a lot of the seals had to be made on site, so a lot of butyl had to be applied on site, and they didn't do it right. And then also there was some bad design plans in terms of how the parapet intersected with the roof that were not an air barrier. So those also created leaks, and they all had big bubbles.
My favorite project, I would have to say, is that historic dorm that they renovated at
a college in the south.
College in the south, yes.
Oh.
So they were having mold problems, of course, and they called us, and we got to be there while they demoed one of the suites in the dorm to figure out how it was really constructed. So we got to see the different phases of construction, from the original stone masonry wall to what they tried to add in 1980s. And then we got to help them fix it and put it back together right. And they ended up demoing the interior of the whole building. I think it was originally built in 1911. And we got to work with them on demoing the whole interior and putting it back together right, so they didn't have any more moisture problems in their dorm.
Yep, that was a good one. I always liked the building. I'm going to take another one. Just as a generic thing, when somebody says, I want you to come and look at the building, we're having some problems, and it's a little problem over here, can you figure it out? And I stand on the front steps and just, with building science knowledge that we've accumulated over many years, just look around and see, I see that's a problem, and that's a contributor, and there's another issue. Oh my God, this is a disaster. That little problem is just a canary that's having a flu. But why is the canary having a flu? And and then looking at it with an infrared camera and just visualizing all of the bad air leakage in the building, and it's not very happy for the client, but it's a rewarding thing to be able to show them what's going on and what the problems are, and that's the first step in figuring out how to fix it.
I have another one. There was that church building we walked into, and we weren't even there 5 minutes, so we knew what their problem was. And they had spent tons of money putting in new HVAC, tons of money doing mold remediation, because they had mold growing on antique books, and their copy paper was rolling up. And we were there 5 minutes and looked above the ceiling and knew exactly what it was. They had no lid on their building in the south, bringing in all that hot, humid air. I think that was the best one, because she's saying when they turned off that boiler from the reheat system on the HVAC, they were saving $3,000 a month in the summer.
Yeah.
And it took us 5 minutes to figure out what was going on. Describe one of your most difficult projects.
It had to be, for me, legal projects. Because
work.
You're working for builders, and a lot of time builders are doing the best they can in terms of using the knowledge they have and the experience they have, and they get sideways with an owner for some reason, and then the crazy talk starts, and you'll have one somewhat educated in construction management, construction science, talking about another one. It's very difficult. I don't like to do those, but working with builders, I feel like I have to support builders when I can, and when I know that they've done the right thing, be able to support them and do that. But it's not a fun job.
I'd have to say my most difficult project are new construction projects, when they call us into test after finishing the whole building and then want to know why they failed and why they can't fix it now that they're done. They've gone through the whole design, the whole construction process, and they're trying to turn it over, and it's not passing their air leakage test. And we're like, well, it's in the walls, but you already put up drywall, so we can't fix it now.
Well, and usually I know when you do a air leakage contract or proposal, you give them the whole recipe of we can do design review, we can do construction inspections, we can do all this stuff, and talk to them about why that makes sense to do. And unfortunately, I think a lot of people don't really think it matters. And looking at a lot of new buildings and testing a lot of new buildings, it matters what you do in construction and design to make those work.
Yeah.
And if they've done everything right, the design review is easy. And the construction inspections are easy too. But if they have problems, and then they get, they really need the help.
Yeah, and unfortunately, a lot of time the contractor's budget is such that they don't think adding, maybe $9,000 of consulting work on the front end will help them out when they're working on a $25 million project. Oh, that's a good one for Francis. How did you get started in our industry?
Gosh, it was 35 years ago. As a graduate student, I was working in ground-coupled heat pumps at the University of Tennessee, and I applied for a job at Advanced Energy, which is kind of an institution. I think we can say that here. Back then, blower door, there was a lot of different kinds of blower doors. So this is how far back it goes. They used to have a blower door that had a bicycle tube around the frame, and you fit it in the frame, and you pumped up the bicycle tube to make it stay in the door. So we've come a long way.
That's in Gary's Hall of Fame museum.
It is in his Hall of Fame museum. So it was kind of neat being in the beginning of the real building science where we're measuring stuff. I mean, science means you measure stuff and look at it and try to assess how it's performing. And so I was at Advanced Energy for maybe 10 years, and that was a great, working with a group like that was a great way to get into the industry. And, made contacts, while I was there, and, that's how I got started, was, from graduate school. It helped me, I think, to be, coming out of an engineering school. But I remember when I was at Advanced Energy, there was a fellow that we all probably know who had a sociology degree. There was another person with a French degree. It was a whole eclectic group that basically they shared, buildings, liking buildings, and trying to understand how they worked.
I got started because I went to North Carolina A&T for architectural engineering, and when I graduated, I wanted to do energy efficiency and renewable energy type stuff, making a better environment for my kids and for everybody else. And I went to work at Southern Energy Management and got partnered up with you working there. But I was actually originally hired to do accounting work, so that was interesting.
Yeah, and your boss at the time said that you did that just to get your foot in the door because you wanted to work at that group.
Because I wanted to work there, yep.
And then I read your resume and said, she has to work for me.
Yep. I took the jobs doing QuickBooks accounting so I could get my foot in the door and do what I wanted to do instead of go sit at a desk all day at an engineering firm. Describe your career path to where you are now.
Well, I started that's 35 years ago, worked at Advanced Energy. I did that for probably 10 years. And I left there and actually worked for a small company out of New York and did work with an industrial housing company. We did some work with utility programs. We did some works in plants, in industrial plants, building production homes in plants. Some of them modular homes, some of them higher end modular homes, whatever that is. That was very interesting. Then I worked on my own for about 8 years and worked with different companies before you and I worked together. What was fun was to work with a lot of different types of buildings in a lot of different situations. I was able to do that. I worked as a subcontractor to an insurance company one time, looking at back in the big housing boom when everyone was building hotels and condos, and looking to prevent moisture problems in those buildings, because there were a lot of lawsuits about.
Because your insurance does not cover mold.
Well, it used to. It used to, until back there in the 80s, 85, 90s, sometime back then, when they decided this was a bad idea, but they could sell you a rider so that you could cover it, and it would just cost you a lot of money. And our deal was I would look at it, do design review, do construction inspections while the building went up, and they would get a break on the mold insurance. So that was very interesting work. I saw a lot of high-rise, a lot of industrial commercial buildings. That's probably how I transitioned from mostly residential into commercial. And then working at Southern Energy Management, where you and I worked together, we started doing military projects where they were doing the base relocation, a lot of new buildings going up, a lot of need in terms of air leakage. And that was also, the front door of the whole air leakage interest in the country was back when the base relocation efforts had started, and the Army Corps said, basically they had done a survey of all their buildings and found out there was a huge correlation between bad air leakage buildings and buildings with moisture problems. So it was also fun to be in at the beginning of that. I know I spent a little time on the committee helping the Army Corps come up with new standards and protocols. Mm-hmm. You spent a lot more time than I did, but that was really a neat opportunity.
Yeah, so going from accounting to being on the front lines with the Army Corps and doing air leakage testing has kind of transitioned, writing the large building protocol for that. We kind of transitioned to what people are calling building envelope or building enclosure commissioning, and that's kind of where we're at right now, and where we spend a lot of our time is trying to make sure on the front end of new construction projects that they're getting it right the first time, so they don't have to pay us afterwards to come back and figure out what's wrong. So if we can get in the door when you're breaking ground, we can fix it, and you can see us during construction instead of after.
You told me earlier that you took pictures of a building as you were coming into the city. It's like you stopped. It's like, oh, there's a mess. And take some pictures of that.
Yeah.
Maybe we'll come back and see it someday, and you'll have the pictures.
And I'll have the pictures. We've actually done that on a couple of buildings.
Yeah, I know.
I dug through my archives of photos and found them. Driving around, just take pictures, and we'll use them later. What motivates you to continue working in our industry?
Well, for me, it's fun. That's a little weird, but I like reading all these technical books and trying to understand the science. And to me, they're puzzles. When I do a forensic job and I go to a building and look at, oh my gosh, how did that happen? It's a puzzle to figure out A, what's going on, B, I don't like to point fingers, but how did we get here? What decisions or non-decisions or omissions or whatever, led us to this place, and then how to fix it. So for me, I like puzzles, and to me, they're all puzzles. That's the fun part. I do like the idea of energy efficiency and what that does for the environment. I'm not in the production side. I don't care really how energy is produced. To me, it's all. I won't say it's all bad, but it all has a negative effect on the environment. No matter how you produce energy, let's just use less of it, by making buildings work better.
What motivates me to continue working in our industry? I think the same thing, problem solving. So even if it's a new construction problem, you still have a problem you have to solve. How are you going to make this building last its 40+ year life? How are you going to make sure that the people in it are still comfortable? It's all a big problem. You get to learn about new technologies coming out all the time, new materials, new engineered materials that are going to act as an air barrier, vapor barrier, water barrier, all in one, and you just put one big giant coat on your building and it works. So it takes care of all the problems. It's just a big problem, and all the time it's changing and evolving. What market barriers do you deal with on a regular basis?
Ignorance. Is that a market barrier? I guess that's not really a market barrier. Actually, that's our market driver, isn't it? Yeah,
Yeah.
Ignorance, we love it.
Market barrier.
We're really busy. Do we have any market barriers?
I think it's just for building it right the first time. I think a lot of it is education, consumer awareness, getting good qualified subcontractors who are going to follow the directions that they are given by the manufacturer to install it properly. I think that's our biggest barrier.
Yeah, you're right. You're actually right, because and we've talked about this many times, just as far as air leakage, but also as far as moisture problems and other things that we see. That the most important thing is, did you read the directions and follow them? And so many times that doesn't happen.
Even on HVAC though, sometimes it's just they didn't read the instructions to hook it up right, and now it's not working.
Or we read the instructions, but we're going to take a shortcut anyway. And I like to say this about high performance buildings, that there's an analogy like driving a high performance car. If you've ever driven a race car, you can get off the track really fast and really easy. And I think that's a truism about high performance, is that it's easy to crash a high performance car, motorbike, boat, and a building. So you really have to follow the directions and make sure everybody knows what they're supposed to do in construction and even in operation. I mean, it's not as simple as it used to be, but it performs better. So it works out, but you have to do it right.
Read the directions. What market opportunities excite you the most?
I don't know. Let's see.
I think in 10, 15 years, all this multifamily and mixed-use buildings going up are going to be very interesting from a forensic standpoint.
Yeah, I think that's a good opportunity. Certainly, we've seen lots of multifamily go up very fast, and we were looking at some of them today with building wrap that just didn't look good at all. And some other issues, and how they're going to resolve those 10 years down the road when they start to smell bad, I don't know, but certainly there'll be a lot of those.
I think also how they're separating the commercial, like in the mixed-use buildings, how they're separating the commercial from the residential levels, and are those really airtight? Are we going to see problems with, like, if restaurants are moving into those mixed-use spaces, are we going to have odors in the apartments above because they didn't get something right? I think that'll be another opportunity, interesting thing to look at.
I think I'm also really excited about net zero buildings. That's a cool thing, and here we get to marry the renewable energy with the really good building that performs well. I think there's a lot of solar companies now. They focus on the solar, which is great. As soon as we can marry that to the high performance building, then we'll have net zero. And I know a lot of people are doing it, but it's not a mass thing yet.
Yeah.
And as it comes out of the development stage to where it's really a production thing, that'll be real exciting.
And as the energy modeling programs advance and kind of catch up with some envelope testing, that'll be fun. All right. What help does your business need in order to grow and prosper? A new website.
Well, just communications in general, I think, is what I hear you saying. And for us, networking, kind of in a very informal basis, is how we, how we get work and how we, communicate about what we do. And, so having a good network organization where, people know what we have to offer and we know what people have to offer is really, I think, something that we could benefit from. We're a small company. We're, on a bad day we're 2 people. On a good day we're 4 or 5. Because we have some part-time people that work with us. It's hard to network and communicate as much as we have to if we have to do it all ourselves. So a good organization would help do that.
An administrative assistant to manage you.
To manage me? I think you're asking for a lot.
Let me see. Help. I think the biggest help if we want to stop seeing problem buildings is to educate subcontractors and contractors. I think if we can get the contractors on board a little bit better for high performance buildings and building performance overall, if we can educate them a little bit more, get them on board, I think that'll help out a lot. It'll keep us from getting as much forensic work, but it will help us, there won't be so much fighting on the front end of new construction projects.
Well, and that's interesting because, we both do a lot of presentations, but I can't remember in commercial and industrial buildings where we've done a presentation for the people who actually build the building.
I've done one.
We've done one.
In 10 years.
Yeah. And otherwise we're talking
it wasn't in North Carolina either.
Architects and the owners and the engineers sometimes. I won't say we're speaking to the choir, but there's a little bit of that going on. And the contractors, I think a lot of them, really truly believe they're doing a great job and really have no clue that, they're just missing the boat on some of these things. I've never met a contractor who didn't want to do a great job. But they've learned some shortcuts, or they really don't understand how these things integrate with each other. And again, we're dealing with a high performance building, so things that you could would slip by and be okay in a building that was built 10 years ago, won't cut it in a building that you aspire to be high performance and maybe aspire to be a net zero building.
And I think another misconception that some people have is that building code means high performance. Building code is minimum standard. It's not necessarily a high performance standard. It's not necessarily best practice. That's the bare minimum to get your certificate of occupancy. It's not a high performance building. It's not a tool to get to a net zero building. It's the bare minimum that you have to have.
Self-learning. There's a lot you can take away from a college degree or a whatever education that you already have. But for me, it's mostly been self-learned type skills. Even coming out of an engineering school, there was not a whole lot that I was able to take directly from my master's in engineering and apply towards building science and construction projects. Having that background really helps, but self-learning is really what I find you have to do. Find workshops, find things on the internet that are good. Be involved in construction. I know when I worked at Advanced Energy, we had some guy come in for an interview, and our advice to him was go build houses for a year and then come back, and he did. And it was really a great thing for him to do in terms of his understanding about buildings and how they come together. And I know several younger people who've gotten into the construction trades, and just to be able to see the inside of a building and see it go up and understand how all these systems have to work together, because that's really the key with buildings, and it's difficult to learn in a classroom.
I agree. I think the what helped me the most, even though I went to school for engineering, was the fact that my dad had worked construction for several years, and so seeing buildings go up, being in the field, being hands-on is probably the best advice for anybody wanting to get into the industry. Is go spend some time working for Habitat, or go work on a construction site to get that hands-on time where you see the whole building go together, you see all the components, because all these different components in the building is what makes it a high-performing building.
And then there's a certain measure of just curiosity. If you're not curious about every building you walk into and look around and say, I wonder what's going on there, or how come I'm uncomfortable at this spot?
Yeah.
That's part of our puzzle. We like say,
walk into buildings going like this.
Looking up and, looking for problems, or driving by a building and have to stop and get a picture of that because, oh my God, I can't believe what they're doing. Mm-hmm. that's a big part of it.
Yeah, us going out to eat in restaurants or going somewhere with our spouse is not fun because they're like, what are you looking at up there? What do you do to learn new skills and keep your current skills sharp?
Probably I'm driven by any project I have to go and get current research on what I'm looking at. I like to think the work we do is research driven.
Mm-hmm.
So if I'm looking at a building and it's got a product I haven't seen before, then I go and get the instruction manual or the installation manual. I'll read about it in Journal of Light Construction or whatever other thing that helps me understand what is going on in the building that I'm looking at. So I keep huge folders of research documents or articles or whatever on any project that I have, and it's the way I do my work. So every project that I do, I have an opportunity to learn something, and I don't try to do it, but I just want to make sure that I'm right. So I look at the research. I don't like to be wrong. So
I think continuing education, whether it's just a webinar. I did a webinar a couple weeks ago on energy conservation measures and duct leakage. Just doing any kind of webinar, any kind of continuing education, even if it's just 30 minutes, learning about some new technology or new material that's out there. I think that's the best thing, because every time I turn around, the architects have some new product that's out and they want us to review it, or have you seen this product go on in the field? Is it easy? Is it hard? Have you had problems with it? So I think that's the main thing, is just learn all you can from webinars, even if it's a manufacturer's webinar on the new product coming out. Name one source that you go to for innovative ideas or new products. Francis.
I can't name one source.
Oh, you were my source.
Oh, I was just, well, I thank you for that, but there's a couple of organizations that I follow, and I don't really follow them the way everybody else does, because for me, following is it's not an internet thing, but I read a lot of Building Science Corporation. I think they have some really good stuff. I read stuff out of Canada because they're in an extreme climate, and some of the stuff they do is driven by the need to perform.
That doesn't mean you can take the house design from Canada and put it in North Carolina.
No. Yeah, that's yes. We try to learn to be a little climate specific in our construction nowadays. And that is also kind of a new thing, that the codes were not written to be very climate specific not that long ago. And the internet, although, the internet is a great tool, I think you have to join organizations and you have to take advantage of them. I'm a big ASHRAE follower. I think ASHRAE is an incredible organization, and they have thought about much of the stuff. I remember driving with someone to a hog facility many years ago, and we were going to consult with a hog production factory. Mm-hmm. And with the ASHRAE book in the car, going through the documents, and here's pig production, and here's all the stuff we should know, reading that as we were in the car, because that's what we did. So ASHRAE is a great organization, but I think whatever organization, find out if it gives value to it, and be involved. I think that's what I do.
I think a good source is other people in your industry. Networking with them, finding out what they're doing, what problems they're having, or if you're having similar problems, or if you're having the same successes in your industry, will tell you a lot too. And there's people we compete with, but we don't really compete with them, because we'll call them, be like, hey, I need help on this project, or hey, I'm got too much work. Do you mind calling this client and working with them? I think it's more knowing people in your industry and working with them is a good resource. Is it possible to have a 30 to 40 year career in our industry?
So far, yes.
Yeah?
You know,
Are you
like
sure?
well, I've been working in the building science for about 35 years. And again, starting with advanced energy, many, many years ago. There were lots of ups and downs in my personal path to where I am now. But you know, it's all been learning, and it's all been productive in terms of my movement towards where I am now. And yeah, so I think that's the easy answer.
So you'll keep doing it for another 30 years?
Well, I don't think there's another 30 years left. I'll give it another 10 anyway, and we'll start with 10 more years, and we'll see.
Okay. I think it's possible. I think as long as you don't get burned out and it's still something you love to do, I think there's no reason why you can't do it for 30 to 40 years. But the second it stops becoming fun, you won't want to be here anymore.
Well,
we'll keep it fun.
We do keep it fun.
What do building owners and operators not know about their buildings?
Everything. You know, building owners, you know, I won't say they don't know everything.
Water dripping from your ceiling does not mean a roof leak.
Well, that's true. I think their priorities as a building owner are not necessarily with the building itself. The structure. You know, you don't own a building. You own a business in a building. You have people in the building, and those are the things that you really focus on. And you know, in that sense, a lot of the building problems that I see are a distraction to them. It's like, oh my gosh, I don't have time to deal with this, because in their mind that takes up 90% of their mental pie chart. You know, is the people in the building and what they're supposed to be doing, and the other 10% they hope the facilities guys can figure out. So I don't think that's true about every building owner, but a lot of building owners, it is true. And you know, because we get crazy stories about, you know, here's what's going on and this is why. And usually, you know, the interview, I like the interview when I'm doing a forensic work, because I always listen to it very carefully, because they will say something. You know, again, it's like a puzzle or a mystery novel. They'll say something that's right that they don't even know they said it was right. But you know, so you have to really listen and pay attention. But usually, you know, their conclusions about why water's dripping through the ceiling, you know, are all wrong. But they say it started in May, or you know, but it only happens in the summer. All those are clues that, you know, point us in the right direction to figure out what's going on with the buildings. But the building owners, they don't know a lot usually. It's my experience. They don't know where the plans are. What does it say? What don't they know about the buildings? They don't know where the plans are.
When the building was built.
They don't know where the operation manuals for the equipment is.
Or when the equipment was installed or figured that.
Right.
Sometimes it's not necessarily the owner and operator's fault. Sometimes they've acquired buildings over the years, and they were basically handed, oh, here's this building, and not given any information. Sometimes we'll get an operator in a building who knows that at 10 o'clock every day he has to go turn the 2-pipe water system from heating to cooling, because otherwise he gets too many complaints from the tenants. So they're good at managing the tenants and managing the complaints from the tenants, but not necessarily how the building is functioning as a system. They're too busy with this wall is stained and it's cold. What will a high performance building look like in 2024 and 2030?
Well, if we believe ASHRAE and BOMA and a few other organizations, we will be moving towards low energy net zero buildings. You know, that will be very exciting in a lot of different ways. You know, for me personally, it's because the buildings will have to perform really well, just the building itself, regardless of, you know, where its energy comes from. So I expect to see new products all the time. I mean, you know, to me personally, we've seen an explosion in new products. If you look at how many exterior things we hang on buildings nowadays, there's way more than there used to be. So
it's not just brick cladding anymore.
Not just brick cladding, not just, you know, exterior sheetrock. I mean, there's tons of stuff that we put on the outside of the building, and I can only see that increasing.
I think the architects are getting more creative in their design, so they might look more futuristic, but I think inevitably they're going to have enough, I guess, renewable or generate their own energy to offset their performance. So that would be, I guess that's what I want to see.
So you think houses are going to get rid of their little colonial facade that we've had for 200 years, where they all have?
Not necessarily houses, but like on the commercial side.
Okay.
I think they're going to be a little more creative.
Mm-hmm.
Unless they're in certain jurisdictions that tell them they can't be.
They can't be creative.
I won't mention which center doesn't like. Drop some industry wisdom on us.
I
Build it tight and ventilate right.
You like that?
Well, I'm tired of explaining it to people. If you build your building tight, it's not going to make people sick as long as you ventilate it right. So all these new buildings that we're building, and we're tightening the envelope to control where the leakage is from, as long as you have that ERV to bring in fresh air, we can tighten the envelope. It's not going to make people sick. So those builders who think that we're making the buildings sick, they just need some ventilation.
Okay. I don't have anything
You
to
don't
add.
have any?
No, I don't. And that.
No mold stuff?
Well,
No indoor air quality stuff?
we talk about just moisture problems in general. Is still the thing that destroys more buildings than anything else. Hurricanes, fires, whatever, moisture problems is the biggest, destroyer of buildings.
But it's not because you need a vapor barrier all the time.
No,
Because that's another common misconception, is you need a vapor barrier. Well, a lot of the problems we found in buildings, they think is related to vapor intrusion, and it's not really. It's other things. Air leakage, or you have a roof leak and you didn't fix it, or you had a pipe burst and didn't fix it until you moved out 2 years later.
The house is a building is a system.
Mm-hmm.
All the system has to work together. Can you build a house with the vapor retarder on the inside? Yes. Can you build it with the vapor retarder on the outside? Yes. You can do all that. You just have to engineer it right, make sure it gets built the way you planned, and think climatically about what that wall assembly or roof assembly needs to do. I think engineers will tell you they can build a sustainable building tomorrow. It's just somebody has to want to pay for it, and I think I think that's kind of an interesting thing that I think about, is this whole thing about sustainability and what is sustainability and defines sustainability. To me, it's easy. A 2-year payback is not sustainable. I mean, that means we
did everything possible in 2 years.
Yeah, everything has to pay for itself in 2 years. Sustainability means long-term horizon. So sustainability should start meaning that you're planning for the long term. You're building a building that you want to last more than 2 years, more than 10 years, and I think that's the other thing, is this is an investment, and taking shortcuts all the time in buildings, is not the best sustainable approach.
Or value engineering things out because of the upfront cost.
I like where we used to work, and people would say, we want some of that sustainability stuff, but it's got to pay for it in 2 years. It's like, well, okay, there's a few things you can do, but really, to look for the long term, that's that's my definition of sustainability, is it doesn't have a 2-year payback.
And it's long-term goals.
Yeah.
Yeah, because you're not designing your building to last 2 years. You want to design your building to be 40 plus years, or like the renovation project we did. That building was built in 1911, and they're still using it.
And we talk about value engineering like it's a bad word all the time, and it's not. But you have to put your value in the right place. I mean, the value should be not just where can we save money, but where can we improve performance.
And what's going to last the anticipated life of the building.
Yep.